Good day guys, you're welcome back to this channel. In the last class I gave you some assignments which you can see on the board. Let's look into the solution to the assignment together before we go to the topic of the day. On the board is the assignment. Given that N, Y, P and E are smaller sets of numbers that take their elements or members from a larger set of numbers -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Where N represents natural numbers, Y represents positive odd numbers, P represents positive prime numbers, E represents positive even numbers. Use the information above to answer the questions that follow. Question A. List the elements of N, P, E, and Y. B. What elements are common to P and E? The last question. What element from the larger set given above is or are not elements of N, P, Y, and E? Now, taking them one after the other. Question A. List the elements of N, P, E, and Y. In order not to waste time and space, let me answer them in front of each of them. In the exam, you will have, paper to answer them on. But here, let me just manage the space. For N, the natural numbers obtainable from the larger set given unto us above here, they are 1, 2, 3, 4, 5, 6, 7. Those are the natural numbers obtainable from here. Since natural numbers are positive whole numbers from 1 to infinity. But here we have the boundary here. The boundary here is 7. That is the last element obtainable here. Now, Y, which is positive odd numbers. What are the positive odd numbers obtainable from the larger set here? They are 1, positive odd numbers, 3, 5, 7. And those are the positive odd numbers obtainable from the larger set above. P, that's positive prime numbers. Positive prime numbers. And they are 2. Don't forget, 2 is the first prime number, followed by 3, then 5, next is 7. Those are the positive prime numbers obtainable from the larger set above. E is positive even numbers, and that is 2, 4, 6. The next one should be 8, but it will not be obtainable from the larger set given above, so we stop at 6. That is answer to question A. Assuming you are answering this in the exam, I will rub this off. You write A. You now list N is this, Y this, P that, E that. So, but since I'm just listing the element in front of them here to save the space, you understand. Now to question B, I will now use this small space to answer question B. The question is, what element is or are common to P and E? It's a matter of high. P, we have 2, 3, 5, 7. E, we have 2, 4, 6. What element is common or are common to the two sets? We have only one element. 2 is common to them. 2 is here, 2 is here. So we write 2 is common to P and E. That is the answer. Question C. What elements from the larger set given is or are not elements of N, P, Y, and E? Look at the element of N, Y, P, and E. Which element from the larger set -3 to 7 are not represented in any of N, Y, P, and E? You can see it is -3, -2, -1, and 0. They are the elements that are not part of any of the 4 smaller sets. So, -3, -2, -1, and 0 are not elements of N, P, Y, and E. And that's all. You can see how short the answer is. The answer to this short, the answer to B short, the answer to A just as simple as you can see it. The topic for today is fraction. When we say fraction, we all know that fractions are numbers that are not whole numbers. Numbers that are not whole. We have some types of fraction. We have proper fraction. Proper fractions are fractions in which the numerator is less than the denominator. Generally, in any fraction, when we have A over B, the A is the numerator, while the B is the denominator. Therefore, any fraction in which the numerator is less than the denominator, like 2 over 3, 1 over 5, 7 over 10, 3 over 4, etc. We refer to this as proper fraction. Next to that is mixed number or fraction. This is a type of fraction in which we have the combination of whole number and proper fraction, like 3 whole number, 1 over 4, 4 whole number, 3 over 5, 1 whole number, 2 over 7, etc. The fractions of this nature are called mixed fraction or mixed numbers. So we have another one which we call improper fraction. This is a situation whereby the numerator is greater than the denominator, like 3 over 2. This is a good example of improper fraction. 5 over 3, 7 over 4, 9 over 8, and so forth. This is improper fraction. This is improper fraction. This is improper fraction. These are improper fractions. So let's see how we change mixed fraction to improper fraction. Let's look at this example. Example 1. Change the following to improper fraction. Question A. 3 whole number 3 over 4 is a mixed fraction. So changing it to improper fraction, we have 4 times 3 plus 3 all over 4, which is 12 plus 3. 4 times 3 is 12 plus this 3 over 4. And the answer will be 15 over 4. So this is 15 over 4 in improper form. 3 whole number, 3 over 4. In improper form, it is 15 over 4. Question B, 1 whole number, 3 over 7. In improper fraction means 7 times 1 plus 3, which is this, all over 7, which is 7 times 1 is still 7, plus 3 over 7, which is finally 7 plus 3 is 10 over 7. Therefore, 1 whole number 3 over 7 in mixed fraction is 10 over 7 in improper fraction. Example 2. If 7 whole number 2 over 5 is expressed in improper fraction, what will be its numerator? That is 7 whole number 2 over 5. If it is expressed as 7 times 5 or 5 times 7 plus 2 divided by 5. 5 times 7 is 35 plus 2 over 5. 35 plus 2, that is 37 over 5. The answer is, therefore, its numerator will be 37. That's the answer. Its numerator will be 37. Let's take the last question under this subheading. If 1 whole number 1 over 2 is expressed in improper fraction, what will be the sum of its numerator and denominator? 1 whole number 1 over 2 expressed in improper fraction will be 2 times 1 plus 1 over 2, which is 2 plus 1 over 2 and 3 over 2. The numerator in this case is 3. The denominator is 2. So therefore, sum of numerator n and denominator d is, the numerator is 3, the denominator is 2, the answer is 5. We come to another subheading yet under the fraction, changing improper fractions to mixed fractions. Example 1. Change 31 over 7 to a mixed fraction. We write 31 over 7 will be, how many 7 do we have in 31? We have 4. That is, 7 times 4 is 28. So, what remains from the 31? If we remove 28 from 31, what do we have left? We have 3. So that is 3 over 7. That is how to express improper fraction in a mixed fraction. Example 2. Change the following to mixed fractions. Question A. Change 3 over 2 to a mixed fraction. How many 2 do we have in 3? 1. Remaining what? Remaining 1 over 2. Changed already. Question B. 17 over 4. Changed to mixed number will be, how many 4 do we have in 17? We have 4. Because 4 times 4 is 16. So remaining what? Out of 17, remaining 1. We put that 1 over this 4. So we change 17 over 4 to 4 number 1 over 4. And lastly, 35 over 8 is expressed as, you will say, how many 8 do we have in 35? We have 4, because 8 times 4 is 32. So that means we have 4, 8 in 4 places in 35. So remaining 3, that 3 we now place it on the 8. So 35 over 8 is expressed as 4 whole number 3 over 8 as a mixed fraction.